2 in the morning. My wife and my 5 children are sleeping peacefully, as was I before my pager goes off. I run downstairs. I log into my computer. Amazon.com is broken. I join a conference bridge with 30 other engineers, each frantically trying to uncover what has happened, what has gone wrong. Today, I'm call leader. It's my responsibility to manage this chaos, to resolve it, whatever it takes, as quickly as possible. In this outage, there were several things that went wrong. As is often the case in complex and distributed systems, many things conspire at the same time to cause a failure. It takes us 45 minutes to find them all and to fix them. And during that time, Amazon has lost over $1 million in revenue. In the e-commerce space, we're familiar with this type of story. Days like Black Friday and Cyber Monday are days of trepidation, days that we prepare for months in advance. A day that anything that can go wrong will go wrong. And when it happens, these are expensive outages, costing the companies tens of thousands to millions of dollars. On the consumer side, it's an inconvenience. It's an opportunity for a brand to lose trust. But ultimately, if they fail, they will thrust you into the arms of their competitors. You will go somewhere else. You will still put in your code. You will still buy something that you want. We've learned a lot from the types of failures we experienced in this background, but there's a set that are a little bit more critical. As we think about the other industries that are becoming online industries, that are becoming software and technology companies, we can foresee a world where failure is more prevalent. Headlines like these are actually fairly easy to find, and they're happening with a greater frequency. What is it like when your online financial system fails? What happens if you need to withdraw money and you can't? Some poor person received a foreclosure notice in the mail due to a bug, an error on the bank side. And so we see that this is no longer just inconvenient. These are things that are critical to how we run our businesses, to how we operate our finances, to how we are able to live and breathe. But there's an even more serious set that can occur. I could pick on self-driving cars, on autonomous vehicles. There's a variety of more serious circumstances, but airlines have been top of mind for me as someone that travels a lot, for my wife, who is concerned for my safety, and for many people. In the past, these types of failures, these types of chaos and outages were more inconveniences, something that couldn't be booked, something that failed but resulted in just a delay. But with the 737 MAX debacle, we've seen that the price can be much higher. Now, this is a complex failure, as many are. There are many things that have to go wrong, as the system is built to handle individual failures. But in big chaotic systems, those types of circumstances come together. In this case, it was one part finance, it was one part related to the people that operated the planes, it was one part mechanical, and it was one part software related. And when the software didn't do the thing that it needed to do, the outcome was tragic. And so we have had an opportunity as engineers in our career to deal with these types of failures. And I tell you that we take it very seriously. It is our job to ensure that the systems we build are safe, are reliable. So let me pull back the curtain a little bit and show you a little bit what it looks like. This is the picture I refer to lovingly as the microservice Death Star, because it looks like a Death Star. And what are we looking at here? Well, we're looking at something that's very complex, very chaotic. Each of these boxes is a server or a host. These lines are communication that happen between them. And if you're looking at this saying, how am I supposed to make sense of this? What does this mean? Well, that's how we feel as engineers. We have to try to manage these systems, operate them, ensure that the right things happen. In the old world, our systems were a little bit more straightforward, a little bit more simplistic. We could think through everything that could go wrong, and we could test it. Our systems didn't change as often. We might only ship code once a quarter, once a year. Today's world looks much different, with the migration to the cloud, with innovation being king, and speed of execution a competitive advantage. Our systems are changing, not in the order of weeks and days, but on the order of minutes and hours. The system that we tested yesterday is not the system we're operating today. Now, if we're to zoom out a little bit, you see a picture like this. This isn't a galaxy. This is the internet. Arguably one of humanity's most chaotic, complex systems that we've developed. One that's responsible for a great amount of innovation, lots of improvements, efficiencies, lots of conveniences that have come from this. But there's a catch. It comes with this added complexity, this added chaos. Our online systems are always in a state of failure, believe it or not. There's always something not working quite right. And the question is, when does it reach that tipping point? When does it fall over and impact each of us as individuals, as consumers of this technology that rely upon it? And so we, again, as engineers, we have a responsibility to help make the internet as reliable as possible so that we can hold up the trust of the people that depend upon us. And so dealing with these systems at Amazon and Netflix has taught us a better way to approach this. It's given birth to a new discipline, chaos engineering. Chaos engineering is where we purposely go out proactively and cause the types of failures that can and will occur. This helps us to understand how the system will react, what the side effects are, and what we can do about them. Ideally, this is helping us to find things that would result in a large disaster and prevent them from ever occurring. Now, you might say, that sounds like an interesting idea. Is that a good idea? And honestly, as I started, that's often what the question I would get. Why would you do this? This seems like a bad idea. So I often explain things with analogies. And I found that the vaccine is a very apt one here. If we went back 200 years and I said, hey, I'm going to inject you with this disease, are you okay with that? You might have got some pushback. But we know that there's a lot of evidence that supports how our immune systems can be strengthened, how our bodies can be taught to reject these foreign agents, to protect ourselves. Now, it's not a permanent fix. Those entities, those agents can reoccur in our systems, but our bodies have learned how to fight them. And so when they reoccur, they won't take us out. They won't spread throughout the whole system. We can contain them, and we can continue on living our lives. This is the same in our complex online systems. We need the opportunity to see how it will behave. We need an opportunity for our systems to learn where the shortcomings are, how we can have them heal and adapt to the types of failures that occur. The other analogy that I think is very important here is that of the fire drill. Who's grown up participating in fire drills? Pretty much everyone. There's a good reason for this. Fire drills help us to keep us safe. When an urgent situation happens, when a disaster strikes, that is not the time to run around with our hair on fire. We want to react calmly, professionally, thoughtfully. It's a time where having practice beforehand gives us the muscle memory to do the right thing when panic strikes. This is equally as important in our online systems. Sadly, our industry needs to get better at this. The on-call training I've received as an engineer has essentially amounted to, here's your pager, good luck. You're smart, you'll figure it out. We can do better. We can help our teams, our companies, our users practice for these types of events so that when they occur, we're able to mitigate a lot of the negative effects and ideally prevent it from being a large-scale disaster. Hopefully it's a minor incident. And so as we move as a society to rely more heavily upon the internet, as things such as online financials, as our government becomes an online service, as our infrastructure, as our healthcare, as every company becomes a software company to some degree, and every service becomes an online service that people expect to be available all the time, the bar is high, and we as engineers take this very seriously. It is our duty and responsibility to be able to protect the internet, And ultimately, this is why I left Amazon and Netflix, where important work was done. But I founded Gremlin to be able to go help society as a whole build a more resilient, reliable internet. Thank you.